Now, we are going to discuss how to carry out optimization to achieve one optimized the fuzzy reasoning tool. Now, we have seen that the performance of a fuzzy reasoning tool or a fuzzy logic controller depends on its knowledge base, and which is nothing but a collection of its database and rule base. Now, let us see the scheme, how can you optimize or how can you tune. So, this particular the knowledge base of the fuzzy logic controller or fuzzy reasoning tool, so that we can model the input output relationship of a process as accurately as possible. Now, here what we do is, so this knowledge base of the fuzzy logic controller, that is the database and the rule base, we try to optimize with the help of a nature inspired optimization tool. Now, during this training or the tuning, so what we will have to do is, so we will have to take the help of some known input output relationship, and that is known as the training scenario. Now, this nature inspired optimization tool, so it is an iterative method and it takes a huge amount of time just to converge to the optimal solution, and that is why. So, this particular training or the tuning of the parameters, that is carried out offline. Now, once you have got the optimized knowledge base of the fuzzy logic controller, now we can pass the set of inputs, and the moment we pass a set of inputs through the fuzzy logic controller, so we will be getting this particular output online. So, might be within a fraction of second for a set of inputs. So, you will be getting that particular the output, and that is why once it is trained offline, and now we are in a position to use it online. Now, let us see how does it work. Now, to explain this, we are going to take the help of one numerical example. Now, there are several approaches of optimizing. So, this particular fuzzy reasoning tool or fuzzy logic controller, the first approach is your is known as the GA based tuning of manually constructed FLC. So, what we do is, supposing that I want to determine the input output relationship of a particular process. Now, what we do is, we try to design the knowledge base, which is nothing but a collection of database and rule base manually. So, based on the information we have, we try to design manually first, but that may not be the optimal in any sense, and after that we are going to take the help of an optimizer, say genetic algorithm, so that we can find out the optimal knowledge base for this particular the fuzzy logic controller. Now, as I told that we are going to take the help of one binary coded genetic algorithm here. So, a binary coded genetic algorithm is used to obtain optimal database and rule base of a fuzzy reasoning tool, and let me consider a process having say 2 inputs, 1 output. The 2 inputs are I 1 and I 2, and we have got one output that is denoted by O. The membership function distribution of the inputs I 1 and I 2 and the output O are assumed to be triangular in nature for simplicity. So, this shows the membership function distribution for the first input, that is I 1, and this shows the membership function distribution for the second input, that is I 2, and this shows the membership function distribution for the output, that is O. Now, both the inputs and the output actually are represented with the help of 4 linguistic terms each. For example, say the linguistic terms are low, medium, high and very high. Now, there are 4 linguistic terms for I 1 and 4 linguistic terms for I 2. So, I will have 4 multiplied by 4, there are 16 possible combination for the inputs, and we are going to consider the 16 rules, and each rule is nothing but the relationship between the inputs and the output. Now, as I told that for simplicity we have considered that membership function distribution is triangular. So, for this medium and high, so we have considered isosceles triangle, and there is overlapping region also, and for this low and medium, in fact, we are going to consider some sort of your say right angle triangle sort of thing, and similarly for this I 2 and O. So, we are having the membership function distribution for your the low, medium, high and very high, and here once again low, medium, high and very high. And once you have got the membership function distribution, as I told, now we are in a position to design the rule base. Now, here we have got the 16 rules. Now, the 16 rules can be read as follows. For example, the first rule could be, so if I 1 is say low, so I 1 is low and I 2 is your low. So, I 2 is low, then your output O is also low. So, this is actually the first rule. Similarly, we can design all the 16 rules. Now, this shows actually all the 16 rules, manually constructed 16 rules. Now, the designer will design, so this particular the rule base based on his or her experience on that particular the problem. Now, as I told that a particular rule is nothing but the relationship between the inputs and output, and let me read once again the first rule, and which is as follows. If I 1 is low and I 2 is low, then output O is low, and similarly we have got say 16 such rules. Now, I am still continuing with the statement of this particular numerical example. So, here once again let me tell that a binary coded GA will be used to optimize both the database as well as the rule base of this fuzzy reasoning tool, and here we have got the set of training cases, and a particular training scenario is nothing but the relationship between the inputs and output. For example, say the first training scenario is nothing but if I 1 is 10 with some units and I 2 is 28 with some other units, then the output is nothing but 3.5 with some other unit. So, this is the way actually we can design, and we can collect in fact the known input output relationship, and that is nothing but the set of training cases or the set of training scenario. Now, here we have got say capital T number of training scenarios. Now, once you have got this particular training scenario, so now actually we will have to design that particular the GA string, the GA string for the binary coded GA. Now, this particular GA string will carry information of all the design variables. Now, what are the design variables? Let me have a look first, then I will concentrate here. Now, the design variables could be your, so this particular the B 1. So, B 1 is going to represent whether this particular triangle, whether it will be a steeper one or it will be a flatter one. For example, say if it is a right angle triangle, so this indicates the base width of this right angle triangle, and if it is isosceles triangle, so this indicates B 1 indicates actually the half base width of this particular the isosceles triangle. Similarly, for this particular I 2, so B 2 is actually the variable. So, B 2 could be large or it could be small. Similarly, for this particular output, so B 3 could be your the design variables. Now, we will have to assign some bits to represent. So, this B 1, B 2 and B 3. Let me assume that I am assigning 5 bits to represent each of the variables like your B 1, B 2 and B 3. Now, once you have assigned, so some bits like 5 bits each to B 1, B 2 and B 3. So, now we have got in fact your for 3 variables. So, 5 plus 5 plus 5. So, 15 bits to represent B 1, B 2 and B 3. Now, I will have to represent the rule base. How to represent the rule base? I have got 16 rules. Now, to represent in fact the presence or absence of rule. So, we use either 1 or 0. Now, if it is 1, it means that that particular rule is present, and if it is 0, the rule is absent. Now, what we do is, so this indicates actually the rule base. So, we concentrate on the leftmost top corner. So, we start with this, okay. Then we just move in this particular direction, next we move in this particular direction, next we move in fact. So, this particular direction, next we move this particular direction to represent that particular the rule. And what we do is, so if there is 1 here means that particular rule is present, if there is a 0 here means that particular the output is absent, means your that particular output is absent and so on. So, there are 16 such rules. So, I need in fact 16 bits just to represent whether the rule is present or not. So, the GA string will consist of, so 15 for this B 1, B 2 and B 3. So, this is for B 1, B 2 and B 3 plus 16 for the rule base. So, GA string will be your 31 bits long. So, the same thing actually I am just going to represent here. Now, if you see the GA string are present in this particular population, which are generated at random, the first 5 bits is going to represent the B 1, the next 5 bits are going to represent in fact your B 2, the next 5 bits are going to represent B 3 and the remaining 16 bits are going to represent is your the rule base. So, the rule base is represented by, so these 16 bits, this is going to represent B 1, this is going to represent B 2 and this is going to represent B 3 and the GA string will be your 31 bits long. And similarly, we have got the whole population of solution generated at random. Now, once you have got this, now let us see how can it optimize, how can a GA optimize that particular the database and the rule base. Now, before I proceed further, so let me finish the statement of the problem. Now, in fact, so our aim is to determine the deviation in prediction for the set of training scenarios. That means, once it is trained, so we are going to pass a set of say inputs as the test scenario and we will try to find out what should be the output and how much is the deviation. And here during the optimization, so these are the ranges for your B 1, B 2 and B 3. Now, these are all real variables and we will have to define the range for your this B 1, B 2 and B 3. So, this completes actually the statement of the problem. Now, let us see, so how to find out a solution for this particular the problem. Now, this particular method I have already discussed little bit. So, let me discuss once again. Now, let me concentrate on the first GA string, which is 31 bits long. So, this particular GA string is 31 bits long. So, first bit is going to be represented the B 1, the B 2 is going to be represented by the next 5 bits, the next 5 bits are going to represent B 3 and the 16 bits are going to represent that particular the rule base. Now, we have already discussed like how to find out the decoded value. Now, if I try to find out 10110, so this place value is 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4. So, the decoded value will be your 2 raised to the power 4 is nothing but 16, then 2 raised to the power 2 is nothing but 4 plus 2 raised to the power 1 is nothing but 2. So, this is nothing but 22. So, this is nothing but is your the decoded value. And once you have got the decoded value, and once again we will have to use that linear mapping rule, which I have already discussed, and using that linear mapping rule. So, I can find out what should be the real value for this particular the B 1, that is the first design variable. Now, following the similar procedure, so I can also find out what is B 2, then what is B 3, and once you have got the real values for this B 1, B 2 and B 3. So, now in fact, we are in a position to find out like what should be the modified membership function distribution. So, the modified membership function distribution will look like this. So, the starting value for I 1 we keep it fixed. Similarly, the starting value for I 2 is kept fixed, starting value of output is kept fixed. Now, we are going to find out what should be the modified value for this particular your B 1, and depending on the values of this B 1, B 2 and B 3. So, this is your B 2 and this is nothing but is your B 3. So, we redraw the modified membership function distribution. So, the modified membership function distribution for I 1, I 2 and O will look like this. And once you have got the modified membership function distribution, now we are going to discuss like how to select the good rules with the help of the GA string. Supposing that these 16 GA bits lying on the first GA string are going to represent the presence and the absence of the rule. Now, this I have already discussed that this represent actually the output of the rules. So, I 1 has got 4 linguistic term, I 2 has got 4 linguistic term. So, this represent actually the first rule. Now, if I just write down your, so this particular GA string here, so this is 1, so this particular 1, then there are 3 zeros 0 0 0. So, I am here, next is 1 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 1 1. So, I am here, then 0 0 1. Now, 1 means your, so this particular rule is present, 0 means this rule is absent and so on. So, this is the way actually we can code in fact the rule base inside the GA string. Now, once you have got this particular thing, now actually what we can do is I can pass a particular training scenario. Now, the training scenario is something like this. The first training scenario. So, if I 1 is 10, I 2 is 28. So, actually we will have to find out what should be the output of this fuzzy reasoning tool. Now, for I 1 equals to 10 and I 2 equals to 28. So, if you see the modified membership function distribution, if you see the modified membership function distribution. So, I 1 is 10 means I am here. So, if I 1 is 10, so I am here. So, that means I am here. So, this I 1 could be either medium with some mu value or it could be high with another mu value. Now, similarly, this I 2 is 28, that means I am here. So, for this 28 it could be low with this much of membership function value, and it could be medium with this much of membership function value. So, this particular I 1 could be medium or high, and your this I 2 could be, so either this particular your low or medium. So, I have got 2 multiplied by 2, a maximum of 4 fired rules. Now, out of these maximum possibilities we will have to check. So, which of the rules are present. So, to check it, in fact, so what we will have to do is, so we will have to come here and we will have to find out. So, out of these 4 fired rules, so which 1 or which 2 or which 3 or which 4 rules are present here, that we will have to find out. Now, for this particular the problem, so if you see, so out of these, in fact, so only there are 2 fired rules. The fired rules are as follows: if I 1 is medium and I 2 is low, then output is low. The second fired rule, if I 1 is high and I 2 is low, then output is actually your the medium. Now, let us see, now corresponding to this, if I 1 is your medium, so this is the membership function distribution for medium. So, corresponding to this, so I am passing I 1 equals to 10. So, I should be able to find out what should be the membership function value, and this is nothing but the membership function value. Now, this I have already discussed, that using the principle of your the similar triangle, very easily we can find out what should be the membership function distribution corresponding to this medium. And if you calculate, so you will be getting mu m is nothing but 0.83. Now, if we follow the same principle just to find out what should be the mu value corresponding to I 2 equals to your the 28. So, corresponding to 28, I can also find out what is your mu low following the principle of your the similar triangle, and I can calculate the mu low is nothing but 0.13. Now, if you see, so we can find out the mu values. Now, if I concentrate on your the first fired rule, that is nothing but if I 1 is medium and I 2 is low, then output is low. This is the membership function distribution for the low. Now, corresponding to this medium, we have already determined mu m. Corresponding to low, we have determined mu low, and we will have to find out the minimum. The principle I have already discussed, and corresponding to the low value of mu. So, this will be the output, the fuzzy-fied output. Now, following the similar procedure, so I can also find out what should be your the output for the second fired rule. But before that, let me concentrate little bit more on how to determine the area and center of area corresponding to this your the fuzzy-fied output which you have got corresponding to the first fired rule. Now, I will have to find out the area and center of area of this particular the shaded portion. Now, to determine the area and center of area, so what we do is, so this is divided into 2 parts. So, I have got one rectangle sort of thing and I have got one triangle sort of thing. Okay. Now, what you can do is, I can find out the area for this rectangle, that is A 1, and area for this triangle, that is A 2, and I can also find out the center of area. Now, this I have already discussed in much more details. So, I am just going to skip the detailed discussion on this, and because I have already discussed. So, this area A 1 can be determined like this, the center of the area the C 1 can be determined like this. Similarly, the area for the triangle, that is A 2 can be determined like this, and the center of area can be calculated like this. And once you have got this area and center of area, So, now I am in a position to find out corresponding to the first fired rule. So, what should be your the center of combined area. So, I can find out corresponding to the first fired rule, like what should be your the area and what should be your the center of area. Now, this area and center of area I can find out, and so this area is nothing but this and center of area is nothing but this corresponding to the first fired rule. And once you have got this, now we can concentrate on the second fired rule. The second fired rule states, if I 1 is h and I 2 is low, then output is medium, and I can find out what is mu h. I can also find out what is mu low. I can compare. So, this is the minimum. So, corresponding to this, in fact, I can find out. So, this will be the area, the shaded area, and now I will have to find out the area and center of area of this particular the shaded portion. Now, this area I can find out that this is the area of this shaded portion and center of area I can find out. And so, if I know the area and center of area for this particular the fuzzified output of the second rule, and by knowing the same for the first rule, now we are in a position that we can find out using the center of sums method what should be the crisp output. Now, if we follow the principle of center of sums method, very easily we can find out that this will be the crisp output, and once you have got the crisp output, and that is nothing but is your the calculated output. Now, if I know the calculated output, so this is the calculated output, we compare with the target output, find out the deviation. The deviation could be either positive or negative, take the mod value, and this is actually the deviation. Now, this particular deviation is corresponding to the first training scenario. So, this is the first training scenario. Now, we will have to follow the same procedure for all the training scenarios, and we will be able to find out d 2, d 3 up to d t. And after that, actually what we do is we try to find out the total deviation, and that is divided by the number of training scenarios, and that is nothing but the average deviation. Now, this particular average deviation is nothing but the fitness of this particular the first GST. So, this is the GST which we consider, and this is the fitness we got, and this f 1 is nothing but is your d bar, that is the mean deviation. Now, similarly, you can find out the fitness for the second GST, the fitness for the nth GST, and this is a minimization problem. Now, if you use the binary coded J, and if you want to convert, we can convert, is very simple. So, if the objective function is to minimize, so this particular fitness, so what you will have to do is I will have to maximize say 1 divided by the fitness. So, I can maximize 1 divided by fitness just to minimize your the fitness, that is f. Now, we are going to use the operators like reproduction, crossover and mutation. Now, J through a large number of iteration, we will try to find out the optimal knowledge base of the fuzzy logic controller. That means, your optimal database and rule base for the fuzzy logic controller, so that this particular fuzzy logic controller can predict the output for a set of inputs as accurately as possible. Thank you.